All right. I think we're live and ready to go. Welcome back. If this is your first time tuning in, hello. I'm Agent Ultra, and I'm here to hack. We're going to be working on a project we've been working on for a while called LambdaTrek. It's a roguelike game inspired by the Trek universe. If you haven't seen it before, let me just run what we got so far. We're getting pretty close to the end of this project. This may be the last stream. We work on it before we can say that we've got kind of a 1.0-ish release. So let's check it out. The stack, exec, LambdaTrek. Okay, so here we are. We've got our sector map here. And on the right, we have an info panel. You can see different variables about your ship, your shield strength, your hull, various things like that. And then we have a little command palette. Over here, you enter your commands. So you kind of type them in as if you're giving the commands. And we have different screens available as well. So if we press the F1 key here, we got the quadrant map here. So the S is where our ship currently is. These question marks means we haven't scanned the sector yet. We don't know what's in it. But we have long-range sensors that can do that sort of stuff. And so I went to scan 2.2. Nothing in there, it seems. We have this nice handy-dandy little dialogue area. Last week we just got to adding word wrapping. So that we get these nice kind of formatted lines here, which is super nice. And I think we're going to be continuing on that a little bit this week, where I wanted to get the word wrapping to be dynamic with the width here. Right now it's a fixed size. And I'd like to get scrolling working. This is a scroll, our dialogue area is actually scrollable. So I need to figure out how to make that work. With the UI library that we're using, which is called Brick. It's a fantastic little terminal UI library. So this is a terminal UI based interface to the game right now. I'm not really sure if we're going to do it, but maybe a project we can do in the future is port this to kind of a graphical sort of backend so that we could maybe do a release to more platforms. Maybe it'll be good enough the way it is. I don't know. But there you go. That's what the project's about right now. We've got combat implemented. We got pretty much most things implemented. Procedural generation. All that kind of stuff. So there you go. And we do all this game. This game is written in Haskell, by the way, if you haven't noticed. It's in the stream title. And that's mostly what we do on this channel. So, you're in for a treat. Or not. I don't know. It's up to you. I'm not the boss of you. Games. I'm going to ignore the game settings thing because we kind of have a way to do game settings on the command line at least. Maybe if we get to it, we'll do it from a file. I have experimented even more with trying to get multiple forms going in Brick, but I think you can only have really one. Maybe there's some way to hack around it, but that would be a nice thing, but we can do that in a later update to it. But for now, let's focus on the dialogue area, because that's really what I want to work on. So, line wrapping is good. I don't know if we need the custom widget thing. Yeah. What we need to do, though, is get the dynamic word line length. And pass it into the word wrapping. So that's what we're going to work on. Try and make that work. Let's get the code. Source. We're going to go LambdaTrek, and under UI we have wrap text. This is where we do rendering the wrapped text. Found a handy little library called text.wrap for Haskell. Lets us wrap the lines, but it's this number here is a hard-coded number. We want to make that dynamic. We want that to be passed in. And I need to get that number from the size of the containing container for this widget. So we have to figure that out. Well, the first things first, let's get rid of that hard-coded 30 by making it a parameter to the function. call it line width. And there we go. Okay, let's get our builder going. So we use just the test runner with the fast option and the file watch option. There. And that'll just continuously run our tests, rebuild our project, all that sort of stuff. Handy dandy. Okay, so we got build problems because we just changed the type of that function. So that's in the UI. Let's go to the UI code. Under dialog. There we go. So let's just put that hard-coded number there. And that should compile again. Okay, so now we just have to figure out a way to get that number from our container where we are. That's going to be trickier. I don't know how to do that yet, so let's ask Brick. How do we get the size of our enclosing container in columns? So when you're looking at a VTY, like a terminal-based interface, you know, everything's kind of like laid out in a grid, or there's like each of these is like one column. So hopefully you can see that on screen. If I can't make this bigger or smaller. But when I highlight like a line like that, I'm actually highlighting a bunch of columns. And there's like a bunch of rows here. So I'm going to next row, next row, next row. So we want the number of columns wide that this area is going to be. And if we change the size of this, it's changed the number of columns. And I think that information is probably somewhere inside our tree of widgets that we can hopefully query. So let's see. So we have widgets core. There's this text width class. A class of text types that have widths measured in terminal columns. I wonder what things implement this class. Text width for text string, it looks like. So you can build a widget from a text value. Does widget implement that class? Doesn't look like it. Applications, viewports. Well, it'd be pretty wild if I could also get it hooked up so that it does, as it's we get resize events. That would be neat. So we can update the text width of the word wrap as the window's resized. Like it's a favorite thing of like web developers to do, you know? Like, ooh, is it reactive? I should be able to do that too. That would be super sweet. So we get brick events. We get VTY events. Those are like terminal events, I guess. App events, so these are ones we define ourselves. And we get mouse down and mouse up. Let's get the current rendering context. Ah, this might be what we want. The rendering context. This tells widgets how to render, how much space they have in which to render, which attributes they should use to render, which bordering style should be used, and the attribute match map available for rendering. Cool. Oh, available width. Lens. Okay. Get context. Now render M, which is a reader T with context as state. And communicate rendering parameters to the widgets as rendering functions. Okay. So I don't think we have render M context here, do we? If I try to... No, I don't think I do. Extent of a named area. That would be super useful to be able to get the context. Get render state, reset render state. And that might be our way in, maybe? Sounds like we're going to need maybe something like this for our scrolling stuff. Coo. Display region might also be a way to... By the region width, we get an int. If we can get the viewport for the scroll area. Okay, so... Vector dialog. This is where we get the viewport. Sector dialog, I think, is the name. Yeah. Yes, yes, yes. Okay, so I think the way we can get it is by pulling out our viewport, getting its display region, and getting the region width on that. That's my socials. There we go. Okay. Yeah, so maybe dialog viewport. Pull out this part here. Put that back in here. Lowercase b, maybe? Yeah. Okay, so we're constructing each dialog line as its own widget. And then we combine them all into a bunch of text widgets. Well, I guess kind of picture widgets. Pictures being like VTY pictures, because we're doing all our custom word wrapping in there. So I guess that probably means we got to take the size of the dialog viewport and pass it into our combined dialogues. But since we're using a function chain here, yeah, I'm not sure if we can get the size of it out just yet. Let's see if this works. Something, some function on the dialog viewport would be nice. E left, E right fits there. Not getting all of the bindings. Because let's add in region width on the, to get the display region, then we'll add the region width. So viewport. For that viewport, yeah. Look up viewport. What happens in an event handler? Anyways, let's look at the viewport back forward again. Viewport. It's underscore veep size. So we get, this is a VTY display region to see where this hole is. Okay. And then from the display region, we want the region width function. Call that viewport display width. Okay. Region width is not in scope. This does come from graphics.bty.image. Yeah, that's right. VDY, which we have imported already, because we're gonna start. And that's lowercase b again. Okay, so this is a widget. Yeah, it's still a function, that's what I thought. Okay. Not gonna quite work this way. Because the viewport function here is building a widget. So we have to go from widget to something else. Show the core widget type. Just go to empty widget, go to widget. Oh. Oh, this is gross policy. Okay, that's not quite it. Ah, the widget's rendering function. Okay. Interesting. Okay, so this is the render M context. So if maybe we built it as like a custom widget, we implement our own widget function, our own render function for that widget. We can use some of those functions we're looking at to get the rendering context to see how much space we have to render in. How are we doing the individual dialogues right now? I'm taking a dialogue and we're returning a widget name using the vdy.string combined with render wrap text and returning a raw. So raw constructs a widget. We might be able to, yeah, we might be able to do it that way. And then we wouldn't have to thread through the size necessarily. Let's try that. Okay, so let's see. Do we need to keep any of this, or can we just back out? Render wrap text. Yeah, that changes fine. We'll get rid of the stuff in UI. Back out of that. Okay. So then, go to UI. So instead of using raw, we're going to construct our own widget. So we need to give it a size policy, growth policy, and a render function. So dialog string is a VTY picture, so hopefully this will be pretty easy. have to see. Let's put in what size, like, I think it's just greedy and fixed. Yeah, so we'll go greedy. Okay, so there's our render M thing in here. All right. Okay. What are we gonna put? What can we put in there? Render M. Let's go. Let's go. So reader T. So we can get context, the current rendering context. There we go. So let's get that. Get context. Okay, so we have the rendering context. We can get the available width. So we might need to pull this into our block. Move this up here. So that 30, we're gonna, instead of hard coding it, we're going to get it from the available width L off the context, which looks like a lens. So under context, I'm going to view the, I think, put those together like that. And we're going to avail width L. And then we'll put another hole here. Here, non-scope will render CTX. There we go. Cool. Okay, so everything's good so far. And then we just need to do whatever raw does to contain our dialog stir. Let's just look at the source of raw. Empty result. Okay. In the image L lens. Okay. We'll go apply pure to the empty result of image L and dialog stir. Oh, sorry, it's empty result, and I see a setting. Okay, yeah, I think I get what it's trying to do here. We don't need this. we're starting with an empty result, rendering result type, and then we're setting the image portion of that. That's the setter function. The empty result. Return that. Okay, that looks like it compiled. Did it work? Let's try. We can just warp to, what are we at, 3.3? Let's warp to 2.2. Okay, so we got a runtime error there. And, whew, Brick, nice little error message, Brick, not too bad. Try to embed an infinite height widget in vertical viewport sector dialog. Okay, so we need to be fixed, not greedy. I think that'll be the fix for that. Yeah, let's go over here. Where do we start? There. Let's warp to 2 again. Okay. Oh, there it goes, friends. It's not perfect, but it's pretty dang good. That's probably just because of some minor, like this particular terminal maybe. That with some overlapping of the characters, it looks like maybe. Or something about it just not quite getting the right size, sort of. It's kind of working. I think it might be that we're not quite advertising the right width, perhaps? I like that it's kind of just like as we resize, the widget is getting new data about its rendering context. So every frame it's kind of going, oh, okay. My size is currently this or that. It just might be our image width is not quite right. Like after the word wrapping. That's where it seems to be. Like here we have a full line. And as soon as we go one character over, it's like rendering over that word, over that word, over that word. One more, one more. And now it splits. There. A bunch more space, and then we go one more character, one more character, one more character. And then it splits. No split, still. There we go. Alright, so the width is getting a little off a little bit as we get smaller and smaller. Well, that's a start. I like it. Okay. Let's checkmark that with a work in progress commit. Dynamic word wrapping. Make the dialog custom widget its own rendering render function, so that we can, with the rendering context, figure out the width we have to render in. So I think the bug might be like somewhere between that and the other thing. Okay. So let's just kind of go 1, 2, 3, 4, 6, 7, and then we split. 1, 2, 3, 4, 5, 6, 7 characters, 8, 9, 10, 11, 12, 13 characters. 2, 3, 4, 5, 6, 7. It's pretty consistent. I wonder, let's see, with wrap text, line width, the line width, the number we're passing in here for the line width is from our rendering context size. Well, it's doing its best to wrap that so that the longest length line is never greater than line width. And we fold this combining function over, vertical combining function over our V2I images of each line. Text. Well, we're not really returning these. The image itself kind of has the size information, I imagine, available for Rick to do its rendering with the image. I wonder if we could be greedy on the horizontal, but fixed on the vertical. Yeah, that's the first one. Let's try that. And if we get that done, then we can go to scrolling. And if scrolling is pretty quick, we might have some time actually to do some other fun Haskell-y stuff. Okay, compile. Let's check it out. We got some enemies here. Let's long range scan over at 2, 3. Or 2, 2. Okay, we got a couple of lines here. We're still kind of blocking out those characters and then wrapping. I wonder if it's reserving a character in this column here for the scroll bar. Well, it's sort of working that way. At least each line is also word wrapping around. That's nice. Yeah, it must be that we actually are getting a number. Maybe we're not accounting for this. It's 1, 2, 3, 4, 5, 6. Maybe if we account for the length of this prefix string, that will be the actual number we need, word wrap needs, in order to figure out how wide to render this bit of text. Okay. Although, I think Brick had a function that wanted us to use to figure out the length of texts. Our class. Width, text width. Was implemented for text. So we might be able to use, maybe we should be using that to... Always use text width. Yeah, okay. So we'll use text width to figure out the width of that. Okay, so we'll pull out those into subparts. Roommate. And roommate. Labeled. And I'll just take this part here. Take this part here. And then we'll get, oh, that's crewmate color. Crewmate name. That's right. Okay, so it should be crewmate color. Crewmate name. So we need the size of crewmate name. Can you be flipped around? Oh, I messed that up a little bit. Oh, sorry about that. Okay. You go there. Rename that to crewmate colors. That was a good name. I'll just call it crew color. And this one will be that crew name. Okay. Okay, so our dialog string length now needs to, or at least for render wrap text, the available width should be the length, the text length of that crew name from available width. Text width, crew name. That maybe is what's probably maybe causing the weird word wrapping. Okay, restart, check it out. Okay, got a little word wrapping off the start there. We hit factor. Ooh. Ooh. That was it, ladies and gentlemen. Beauty. There it is. Nice. Perfect. Ah, I love it. It's so good. Oh, okay, yes. Awesome. That looks great. Okay, that was it. We just had to take that off the available width. You have to take the width of that little prefix bit that we render on the dialog as part of the string. Oh, that's so good. Okay, cool. Works great. So there you go. We've done custom widgets now in Brick in this project. Pretty easy to do. Not too hard. Quite nice. Good API. I like it. Okay. Let's commit it. Word wrapping working. Real nice. Okay, let's rebase those. Pick, reword. Boom. That's good. Good enough message. Yeah. Sweet. Actually, I'm gonna rebase that again. Just reword that. Yeah, it should be add dynamic dialog. Word wrapping. There we go. Okay. So the next thing we need to work on, scrolling. So as we add a bunch of these, we go to 3.3, warp to 2.2, say. Okay, we're gonna get a scroll bar there. And right now, you can't like click on it and drag on it because it's terminal, right? We don't have any keys for scrolling it and handling scrolling in there. So if you want to like scroll up and down, we kind of got to handle that. But like the viewport has functions for doing that, so we should be able to just listen for a particular key event, update that viewport's state to scroll it in the appropriate direction, probably a line at a time. Be good enough. And then, yeah, that'll be sick. I think. Okay, so how do we do that? I don't know. That's our UI code. And we need to go up to app, I think. It's usually where we handle kind of the top level event handling stuff. Yeah, yeah. Okay. Viewport scroll. V scroll by happens in event M, so we're in the right context here. Event M. Scroll the viewport vertically by the specified number of rows or columns, depending on the orientation. Horizontally. Okay, so viewport scroll N. A viewport scrolling handle. We're managing the scroll state of viewports. Okay, how do I get that? Viewport. That's constructor. That's the rendering context stuff. Okay. Oh, we can look up viewport. Okay. Right. Given a viewport name, get the viewport's size and offset information. viewport scroll. I guess that's probably also a good thing to look up in our UI code is if we actually did viewport scroller. Or if we just wrapped it in a viewport. With P scroll bars. Okay, enable vertical scrollers on all viewports and specify widget and draw them. Okay, maybe we need to actually use viewport scroll. That doesn't seem right. No, GHC says it's not right. How do I scroll my scrolly viewport? Oh, okay. I get the viewport scroll from this. Okay. Okay. So in our event handler, let's add one for, I don't know what key to put it on. Kind of want to put it on Vim key bindings, but people need to type. So I don't want to go modal. Maybe like plus and minus. That'd be nice. Pretty straightforward. I think that a lot of keyboards have plus and minus. Most keyboards probably. I don't know the name of it, what they called it, but I'm going to call it that. Don't care about the adders. Okay, pause. Probably in VTY. Graphics of VTY. Input. K escape, K car, KBS, K enter. Up, down. Well, up, down. It's probably best, actually. K up, K down. Yeah, let's do K up and K down. Okay, up, 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 up. Ooh, okay, so we're in here now. Let's get our scroll handle. Viewport scroll. Yeah, viewport scroll. And then we get our name, which is dialog something. Sector dialog. Okay. Okay, so we got our scroll handle. It's in scope now. We got a viewport scroll. That's good. That means we can now de-scroll by. So will it over scroll or will it just, you know, stop? Scroll the viewport vertically about a specified number of rows or columns depending on orientation of the viewport. So we give it a positive number. Let's just say like 1. Scroll handle 1. Seems that will compile. Probably knows its own state, so let's see. So just warp around to a few places. Okay, cool. Let's do a little word wrapping. So we get some scrolling action. If I press up, yeah, okay, it's going 1 line at a time. This should be K down. And then if I do the same thing but for K up, I think we should get it. And maybe -1? Okay, cool. Builds. Let's try it out. Warp to 2. Let's warp to 3, 3. Let's warp to 3, 2. Warp to 3, 1. Okay, and then I press down. I go 1 line at a time, scrolling down. I can't go further than that. That's good. Yeah, that's wonderful. Boom. Scrolling. Magical. Okay, let's checkpoint that in. Scrolling into dialog area. Key up. And key down. Scroll. Boom. That is what we wanted to do. Check and mate. Atheists, take that. Dunzos. Okay, so we'll maybe tackle game generation settings, stop and setting screens at some point. But there's maybe a settings file, but otherwise it's like it's good. It's like it's there. I could probably cut a release from this. So awesome. However, we are not going to stop there for the evening. No. One of our wonderful viewers, when I put out on the socials, like what project should we work on next, they were inspired by the project we were working on to try out using Brick for a little project, and said, maybe refactor a newbie small Haskell program for educational value? Question mark. If it's of any interest, I pledge my small program as an experiment. I would be honored. So I think we can spend an hour, maybe just a little bit shy of an hour, looking at this this code and seeing what's what. could be very cool. So let's give it a shot. Let's see what we have here. Well, let me just make sure, actually, I push up a code for our project today, too. Push that up. There we go. Cool. So I'll make sure you know where all that code goes at the end of the stream. Okay, Just Bees, T-Tending Scheduler. Or Scheduler. Some simple program to help Just Be organize their weekly 15 pieces of people schedule if they're... Okay, cool. Just Be Temple. Cool. Nice. This looks cozy. I love it. Amazing. Okay, so T-Tending Scheduler. So I guess it's like a little terminal-based application using Brick like we've been using. Set the availabilities of all the T-Tenders, toggle, and all this sorts of stuff. Add, delete T-Tenders and things like that. Cool. It's hosted on SourceHut. How do I clone? I don't want to create an account. So let's create... See if we can clone something like that ourselves. Okay. Sweet. We got a Cabal file. Read me a changelog. We just build it. I can't quite build it. I might need to update some things. Projecting split. Okay, yeah. I think I just need to update my Cabal list, maybe. Cool. So let's just take a little stroll through the code and kind of get a sniff. See what's going on. There's our, I guess main is probably our main entry point. Cool, so we got some app state, attribute map, start event, handle event, choose cursor, app draw UI, super. This is calls on main. We get some contents maybe from a file, something like that. And then we call default main. M is brick. Okay, so it's brick main. Initializing the app with initial state. Cool. Okay, so we're building it now. Awesome. Well, let me make this a little bit bigger for the stream. So right off the bat, this looks nice and clean. About what you'd expect. Let's dive in a little deeper. So I'm guessing get TTS. Let's see, we got logic. Okay, TTS and get TRs comes from the logic module. Stock them there. We have some UI functions there, and persistence is what's this get contents comes from. Now, this is a pretty good practice here. I don't use it terribly often in my projects, as you might have noticed. But it is good, because when you're looking at a module and you just have import persistence, you don't know which functions come from that necessarily. If you have good IDE support or interactive support, you can usually figure that out in your editing environment, your development environment. But it's also nice if you're just using plain text just to see where those names come from. So it's a nice thing to do. Yeah. And then we import these from logic. Okay, so why don't we take a look at the persistence stuff? Maybe it's pretty straightforward. First, since it comes first in main. Persistence, there we go. Okay. We import control success. We have some basic imports, system.io, system.directory, ttenders.text, time ranges.text. Okay, GG get contents. So it takes a string, it returns an IO action that might return a string. Okay. Okay. Yeah. Get contents, save contents. So this is using like the very, very basic system.io API for reading and writing files using handles. And those return strings. And that's fine, I think, probably. I suppose this is not a very big file. And so it's not a ton of data to store in a string. But one little upgrade that could be done here would be to make that, to use the text package, read those in as text strings, and that should, yeah, and that should support, I mean, this both, I think they should both support Unicode encodings. But if you needed a specific encoding, you have a lot more options with the text package and the text encodings package. Anyways, I would recommend text instead of string, generally. String is probably fine here, but that would be a small little thing. Text will usually be a little bit faster, but again, this data size is going to be pretty small, probably. So probably not a huge deal, but that could be something. And yeah, like you could, open files and stuff. I think text.io has an IO package as well that might even be nicer. Text.io, yeah. Boom. So has a similar API, so not a huge change to get text into this program. You just use this package, and then you can get contents and stuff, and return a text of the file contents and stuff. So internally, it's doing stuff there. I'm not sure if the system.io like the base package is doing any kind of buffering when it's reading that string in. So, but again, small files, no problem. Handles it just fine. So that's a small little thing. Let's see, what else is there? There's logic. Yeah, that probably has the meat of the program in there. Hey, lens.micro. We've been using this library on the stream in the LambdaTrek project. Been a pleasure using it. Good to see that there. Control the monad. Okay, some basic imports, as you would expect. Okay, looks like we're going to be also doing some I/O in here as well. Cool. Oh yeah, we got save contents here. Good. Okay. So I'm not sure what that is yet, but ttender, I'm guessing, is representing like one of the people who will be working that we need to schedule in this application. Cool, so we got it built. Do we need to do any other setup? Okay, so that's, I guess, what a ttender file will look like. And let's just let's go into the just be tending. Yeah. There we go. Let's check out that Cabal file. Okay, so it's just b-t tending. Oh, cool. Okay, I'm gonna bring it up in my other window. Yeah. Okay, so here's our little program. Very nice. There's our t-tenders. So I'm using up and down arrow. I can move around. Oh, nice little schedule. Yeah, a little width. That's handy. I like this. This is great. Let's use the arrow keys, navigate. Q and A to select a t-tender. Okay, cool, cool. Plus and minus, change the number of slots. Okay, cool, cool. Base, okay. Ooh. Okay, okay, cool. And then F would lock in the assigned t-tender. Okay, F. So if I choose different t-tender. Oh, I see. Okay, and it changed this. So when I'm on Sam here in the left in the t-tenders corner, I can see all Monday. But if I go to Matt, it changes Sally, Rob, John, Amelia, that sort of thing. Oh, cool. And it persists. Yeah, just like that. Nice. Okay. So that's kind of what it does. And we can poke around in that. That's nice. So let's go look at logic again. Okay. Looks like we got some... Maybe we have to support an older version of GHC to compile with. Okay, so there's our t-tender type. That's pretty nice. Okay, so here we have, let's see, custom instance. We're implementing our own instance for t-tender here instead of deriving one. Let's see, show t-tender name as C, and we go name plus times base, show as C, okay. So, right off the bat here, I rarely ever write custom instances for things like this. For show t-tender. Right. Mainly because show is not necessarily for rendering to like UIs and stuff. Show is more of a debugging tool. It's for echoing out the data structures if you're to write some debugging tool or whatever. So you use show there. And it's supposed to print as like the representation of the Haskell data structure, right? And that's almost always like the same, doing it the same way for everything. So that's why it's almost always derived, right? So I'm guessing this is because show is used in the UI somewhere to display the t-tender. Probably in the UI directly, whereas I would recommend using like a separate rendering function for rendering the string as you want in the UI. All right, where do we use show? We use show here. A couple of places, yeah. Just here, total slots, total count, tname, TT. Well, that's it there. A lot of custom show instances. Okay. Yeah, I would. So one small thing you could do here too would be to make the derive show and use some rendering functions, dedicated rendering functions to render these out to the UI. Equality, like, that's not quite so bad. It looks like this equality instance we just consider them equal by name, not necessarily by slots count. I'm not sure why that is. What that's used for. But it might be just a sign that, like, the two concepts are just tied together here into one data structure, and maybe they don't need to be. Okay, what do we have here? We have read maybe TT. I'm guessing that means T-tender. Bring to maybe T-tender. Okay, so we get S as the string, such that name equals, our name is the first of spanning not equal space S. Okay, some hacky parsing code to be able to read a T-tender from a string. That's fine too. If it works, right? That's good. Read maybe TT. So if you just have small parsing tasks like this, where the structure's not very huge, this is a fine function to write. You know, you don't need to pull in a parsing library for this kind of stuff, so that's good. But if you did need a little bit more power with your parsing, the strings are just a little bit more than just like a name separated by some characters separated by a space. Like it's just a little bit more complicated than this, then maybe you might want to bring in parser combinators. There is one in base, so you don't have to pull in a dependency. We use it actually in the LambdaTrek project as well. If you wanted to get more power out of your parsing here. So slot, I'm guessing this represents those little boxes in the UI there. So we have a list of available T-tenders, locked-in T-tender, frozen T-tender. Cool. So I guess those are the different states. And again, with the show instance here. Oh, a read instance too. Okay, this probably... yeah. When we locked in that user, it's like writing out data that looks like this. So this read instance, I'm assuming, is what got saved in that file there. And to read it back in, it uses this read instance. Read a string to slot. Uses read, yeah. So, in this case, I would definitely recommend a proper parser. Read again is meant for like debugging and for like data structures, like reading and writing what Haskell would print out, say at the GSA prompt. Like if I was to pull up a REPL here. Right, and I think we have slot, yeah. So if I had to create a slot here, let's just empty and false. No, it's just semi-group. Oh, okay, no problem. Okay, all right. It's just printing out like what would actually be serialized to the file, right? But when I'm in a REPL session like this, or I'm you know, debugging the thing, I want to see like how Haskell would print it out. Like if I had a let's say like a new type here, foo of A is foo, yeah, foo. This might not be good. It's not going to be, I think. Get foo, and get foo is like inch or something. I'm going to derive automatically show, maybe eq as well. So if I create a foo, right, and I adjust to f, it's using the show instance that I derived for f to print it like this, right? And this string, if I derive read automatically for foo, I should be able to read this string back in and get a foo as well. And so it's not really meant for user-facing parts of your program where you're rendering things or parsing data from files. In this case, it's such a small little program that really it works just fine. And as long as it works and people find it useful, like, all this stuff doesn't matter. However, it would, you know, aid your development if you're at this program to get a little bit bigger, and aid your maintenance to be able to have these kinds of niceties at the REPL, things like that, for debugging purposes and whatever. So, yeah. I'd probably recommend getting into parser combinators and figuring those out yet, and writing a parser for your file format. And you leaving read and show for what they're meant to be used for. So next we have get slot string. Okay. I guess this is a rendering function, perhaps. Yeah, probably used in the UI to render slots. So that's good. Same with this here. Hopefully cromulent. Okay, and then we have row. String. So I'm going to assume this is probably a row in that little in the UI there. Under the schedule. Okay, 1, 2, say Monday. So your 6 days or whatever. Yeah. 2, 3, 4, 5, 6. This is purely a data structure purely for rendering purposes. So again, just fine. Might be nicer to make it a record with like named slots, but that's perfectly fine. Time range, cool. Yeah, again with the show and read. So at least it's consistent too, which is a good thing to have. Yeah. So there's our app state. Okay, so I think this is the main thing here. A little flag for whether we're editing or not. Column index that we're on. The t-tenders, I guess, for the t-tender widget, and the tabular list for the time range stuff. Cool. This is all good. And then our app event handler handles our key events, updating state and UI and stuff. Great. Probably some helper functions, it looks like. I'm not gonna look at these a whole lot. Although freeze TT, I think it's freeze. So we call that freeze function. It freezes in somebody's schedule. Right, it's F, right? F lock in assign T. F maybe is freeze, like lock in. Yeah. So column ID, time range. Let me split this up. Alright, so these are all slots. And string on top. Okay. So we want freeze TT. Takes a time range and gives a new time range. Oh, okay. So it's calling freezio over the different elements of time range based on the column ID, and we have an incomplete pattern match. Column ID is gets an integer. We're not matching on all integers here. Yeah, so this is cool. You're already using lenses here. So there's probably, with the right structure, a way you could define the lenses you need to update the right place in a time range, which would maybe reduce the need for a function like this. But this is fine. If you had used there's a warning flag you can set on GHC that will tell you if you have incomplete pattern matches, and it would warn you about this. Because it could be a sign of an error if you're pattern matching over like a sum type or something like this in Haskell, and you don't match all of the elements in it. It could be a sign of a bug in your program. So people often use that. Lock and TT is the same kind of thing. So you might get a lot of mileage out of... So we're using a similar pattern here of using like a lens kind of thing to be able to set different places in a time range. Using the lenses for the different locations. You could just use a setter lens. Right, and that would greatly reduce the amount of code here. Toggle yo, initial state, that's the setup. Yeah, all good. Yeah, that's all I have to say about this. So, here's the key highlights are, I would recommend just deriving the EQ, the equality, and the show instances, and the read instances if you need them. Don't derive them if you don't need read. Use parser combinators, a parser library. So there's one in base you could get started with. It's not the greatest, but it does mean you don't have to add another dependency to your project if you want to avoid it. Text.parser combinators.readp is the library. I'm going to jump over it here. So this one, right? Very, very, very basic parser combinators library. It's not terribly powerful. So for such a small little program, I'd probably use it for this kind of a project. And yeah, so I've done many streams where I've shown how to write parser combinators. There's an example even in the LambdaTrek codebase where we do our command parsing that uses it. And that might separate out your parsing a little bit more from your data structures. And then the same thing with the rendering. There's a couple places where it looks like the show instance is used for rendering to the UI, which, as I demonstrated, when you're at the REPL and kind of playing around with the code or debugging things, you lose information using that. So they're meant really for developers, not necessarily for users. Let's see, so I derive those. So parsers, and then yeah, just exploit lenses a little more. So using setters on the time range structure would remove the need for this code. Here it could be like a one-line kind of thing. And yeah. And then you could turn on that warning about incomplete pattern matches and start using that. All right. Otherwise, and if you wanted to make it complete, like say you didn't want to use lenses that way, just don't use int. Right. This seems like there's only 6. So you could just make a sum type with all 6 cases and just pattern match on those, and then it would be complete. Right. And you could just do like that. Right. And then instead of pattern matching on 0, you just pattern match on the one. Right, and that would make it complete pattern match. Yeah, okay, that's cool. Let's see, what else do we got? Main persistence and just the UI code. I expect it mostly just be brick code, so probably not a whole lot. Yeah. Cool. I like the little schedule widget there. That's pretty handy. That's pretty neat looking. Oh, well, I'm glad. That's a neat little program. I'm glad you got to do that little project. That's awesome, and that you were inspired to write that. Chibo? Hopefully I'm pronouncing that properly. Thibault? Anyways, yeah, it's great. Great project. So, let's see. We could do like a proper... That was my high-level review. I don't think we have time to do the refactoring this week. But, maybe next week we'll dig in and I can do this and show you how that would work. So yeah, I think I'm going to call it there tonight. So if you want to see the code for LambdaTrek, it is here on GitHub. I'm Agent Ultra. I'm on Agent Ultra on GitHub. I'm Agent Ultra at Agent on my website as well, which is agentultra.com. And yeah, so there's the code for LambdaTrek. You can download it, start, forget, whatever. It's out there, and mess around with it. I do these streams once a week on Tuesday evenings at about 10 after 8 or so in the Eastern Standard Time Zone, Eastern Time Zone. And if you are on the Twitches and you want to like subscribe, follow the channel, set up your notifications, you'll get notified when I go online. Super helpful. And if you're following on YouTube where I back up my stream VODs, then you know what to do there. Subscribe, thumbs up, and all that sort of stuff. Just let me know that you're watching. And yeah, you can also go to the link above. That is to declarative.tv. Declarative.tv is a group of other streamers who do streaming as well, like this, in different programming languages, Erlang, Haskell, OCaml, you name it. And there's a link to a Discord server there where we have a channel for this stream here. So if you want to chat and talk about your projects or what you saw on the stream, you have any questions you couldn't ask on stream, go there, check it out, and yeah, hopefully I can answer your questions and help you out. Or take a look at your projects too. I like seeing what other people are doing with Haskell, and I like helping people learn and explore and expand and try things out. So there's to go for that. The other thing is I'm on the socials as well, on the Fediverse. This is me, Agent Ultra, on the types.pl server. And you can find links to my YouTube channel and everything here as well. So let's see. That about covers it. Thanks for tuning in and watching and following along. May all your monads be free. May your types always check, and hopefully I'll see you next week. Take care out there. Bye.